you've heard and read about it everywhere, right? There's a lot of external actors that are always determined to get in the way, right? So it's important that.
Hello.
Okay. Thank you. I think this should be a little bit better. So we have security best practices that later in the day, Ria and team will walk us through that. And there is also things around network setup, monitoring and observability from a networking standpoint that some of our colleagues are going to walk us through later in the day. So you can think of all these capabilities in a nutshell, goes hand in hand with what we saw in the developer track. So we are determined both to provide best in class for infra as well as on the developer side.
Victoria's Secret digital platform is powered by state-of-the-art commerce engine.
People are coming to Victoria's Secret mainly to purchase the lingerie product. That's what we are so proud of.
As with every organization, we have this classic problem of managing infrastructure, which is not our core competency.
Our primary focus was how we can able to make the website available for the business to scale. We're also looking for agility and innovation and looking for how we can improve those efficiencies.
We have seasonality, which brings in volumes close to 20x times than what we see during a normal day. This is a classic retail problem.
Either it could be for the Valentine's Day or it could be for Thanksgiving or Cyber Monday.
Going to Azure Kubernetes service, the decision was very straightforward. We were able to bring in that auto scaling.
The technology platform provides the flexibility for us to test and validate and then see how we can able to leverage in terms of improving the performance for the customers.
Before we moved into Azure ecosystem deploying, we were doing 9 releases per year.
The team can able to release 30 to 50 features in a month. That is critical for us.
We completed the entire migration in 6 months. And right on the heels of it, we handled the entire holiday season from Azure Kubernetes service. For customers, response times have gone down.
Moving from a landing page to the product page to the add to bag and checkout, if the customer can able to do all of them in a faster pace in a shorter time period, means you got the win.
Our site used to take 6 to 8 seconds to load a page. Now we are talking about 2 to 3 seconds. That is a 3x performance improvement. Safety is a direct reflection of revenue gain for us. We have redefined and re-architected.
The platform is right now, it's much nimble and scalable. So I can say my cost went down and my performance showed up. I'm like, that's a typical graph anybody wants to see, and then we saw that.
Microsoft has been a great partner for Victoria's Secret.
I think the successful partnership is, again, it's always the people. I think people makes a difference in my opinion. So the Microsoft team are the perfect combination. The more and more Microsoft bring new capabilities to make life easier and customer life easier, that's what we need.
So we saw in the morning that about 94% of S500 customers are using AKS. So that's one more testimonial from one of our customers. I think the timing is a little bit off here, but I think we are making good use of the time. As we saw in the morning, we're able to fit the Ask the Expert session that was originally scheduled at 5 p.m. I mean, you don't want to ask questions and answers at 5 p.m. That's after a long day, so we're happy that we're able to shift that before lunch. And now we'll start off with reducing complexity in upgrades, followed by security best practices. We'll have a brief break to recharge and then come back with network setup, full stack observability, and there is to round it off, resiliency, backup, and reliability. So quick show of hands, how many of you attended both, were there in the morning sessions as well? I want to see. Yeah, that's a good amount of overlap, so that's good. And how many from this audience is also planning to go to KubeCon? Okay, it's like 70%, I guess. Pretty good. So I just want to, I'm also a cricket nut, like much like what Lucky was saying, right? So I know in this hall and probably in Delhi, right, just after Kubernetes, cricket is probably the number 2 famous topic, right? So analogy, if you ask me about AKS days, yesterday and today, so yesterday we had hands-on labs, today we have very focused, tailor-made sessions, and our objective is to make you guys successful with AKS, Azure, and have key takeaways and best practices. So that's the analogy for border Gavaskar. It's a little bit of a bilateral handshake, right? And if you look at KubeCon, where you have you jazz it up with open source vendors, you have very good talks on AI, what's happening in the Kubernetes world broadly, and Microsoft is a representative, but you also have the other big names coming in. So that's a little bit like WTC, right? I know there's like 20-30% for want of time or different overlaps, you're not able to make it. As I would be joking to Lucky, what I would say is, if you don't have WTC, we have two border Gavaskar, right? So we're playing for the third. Fret not. So getting into complexity, reducing complexity of upgrade. So how many of you here feel upgrades are fun? Doing Kubernetes upgrades, okay. So the vast majority are like me, I suppose. So that's why we have this session. So we'll get into that. We want to simplify the upgrade experience. So just a little bit of basics for most of you. I know some of you are well versed with upgrades. We want to make sure that we cover the basics as well. So we have control plane agent pool versions that need upgrading in keeping with the upstream community version, right? It comes thick and fast. We'll go into the cadence and other things in terms of the nuts and bolts. But generally, we have control plane agent pool upgrades. We have node pools, nodes that need reimages, right? Why? Because from a security standpoint, constantly, we want to address vulnerabilities there, feature updates, fixes. So all these things are pretty important when it comes to both control plane upgrades as well as node pool upgrades. So people who are familiar with the upstream Kubernetes page, you have a stream of releases. So you have things like alpha release, beta release, and in the Kubernetes community, you have release candidates, RC0, RC1, and then you have preview and GA versions. That's the left-hand side. That if you go into the Kubernetes GitHub link or their pages, you can see that they have a calendar as well. And the right-hand side, you have patches. Besides the minor version upgrades, you also have patches. That's what you see, like 1.30.3, or in this example, 1.25.7, 0.7.5.6. They are the patches. They usually don't come with breaking changes, but important bug fixes and things like that. So there's this two concept of minor version that comes typically every 4 months or so, and you have patches that every other week, or sometimes in faster cadence, you have patches. And we follow the upstream calendar very closely. So we have our own calendar if you go into our docs page. So right now we have, 130 and 131 is GA'd, and it's getting available in all the regions. I know we have a code freeze ongoing, so we'll get with 1.32 very soon in January, February timeframe. That's the idea. So typically, like I said, every 4 months or so, upstream releases a version. We are trying to close the gap, how soon we can follow upstream. Right now, it's about 15 days to 1 month when we, from upstream preview to our preview, and then GA takes 1 or 2 months later. So we are trying to close the gap in terms of how can we do the testing much earlier following the upstream release, like be it RC version or beta version. Can we start there and reduce the cadence of our shipment? So typically we have a stringent N-2 support policy. And again, it's not enforced by AKS, it's an upstream recommendation. So we saw from a vulnerability standpoint, how can we be ahead in terms of security and bug fixes. So that's the main reason we have this stringent N-2 policy. That means you have N-2 version. In our case, if it's 1.31 is the latest one. So 1.31, 1.30, 1.29. Those are the 3 supported versions at any point of time. And that means you end up in the problem of constantly it's a cat and mouse game, right? You have to keep upgrading every single time, at least once a year, into a minor version. And I know that poses a lot of challenges. So if you do AZAKs get versions and choose any specific region like West Europe here, you can see what are all the versions available to upgrade and what is the support plan. We also have a long-term version support that extends besides the community supported version of cadence of 12 months of support. We provide additional 12 months of support. So that's something that available for 1.27 versions and 1.30 right now as long-term support version. We have more planned in the pipeline, so you can stay tuned and learn about it next year. And this is our release tracker page. You have releases, aksazure.com. So you go there, you can see our release notes, which version is there in what region. Typically, we follow safe deployment practices of Azure, and you have all the regions very much mimicking Azure. So in this sense, we have both the AKS releases, the overall component updates and everything, and also at a node image level, what are the VHTs and the images that we ship for your Ubuntu ecosystem, Azure Linux, or formerly known as Mariner, and then Windows ecosystem. So if you click on any of the links, you will have either our release notes, or you can also look at the node image release notes, what it entails. So yeah, if you want to, we definitely recommend upgrading your node images. Typically, there is one every week. We ship an image, especially when you're talking about Ubuntu and Azure Linux. That's a good cadence to keep up, and you have auto upgrade channels called node image that you can choose. And if you have a specific time, you can set up planned maintenance for that. Otherwise, if you want to do it on demand, you can go to the node pool, choose the image of your choice and the node, and you can update it as well. There's also CLI options, as with everything, Bicep, Terraform, and CLI. You have most of these things covered. Whatever you see in Portal, you should have it, because there is a corresponding API. So here you can see that once you create the cluster, you can look at show node AZAK's node pool show. It gives you the node image version. You can also do, compared to the get versions, get upgrades is a little bit tailor-made for your cluster configuration. So it gives you for your cluster what is the base image and what are the upgrades available. And then if you want to just do the node image upgrade alone, you can choose an option as node image only. You can also, besides the node images, we have the concept of auto upgrades. Right now is both node image as well as so node pool as well as control plane together. So you can very well configure the same with manual as you go get upgrades, and then you can choose what version you want to do. Choose the Kubernetes version of your choice and trigger the upgrades. We also have a cool feature that we released last year. I know one of the stumbling blocks for upgrades is deprecated APIs. So at the point of upgrades, we look at your cluster configuration and see if there are any deprecated APIs in tune with what is there in the community. Then it will flag and fail fast or stop the upgrades then and there, and not burn your workloads later. So here is an illustration of from the portal how you can choose auto upgrade channels. We have like stable, rapid for minor versions, and there's a patch channel that we recommend. It's preset as a default when you create a cluster from portal, and you can also obviously choose to choose a version from portal and upgrade as well. So with that, I'll just do a quick illustration of how upgrades work, what happens to your pods, and what are the sequence of steps involved. So let's just take, for the purpose here, I have 3 nodes, all running 1.23.12. I know it's an older version, just for an illustration. And each have 2 pods. Very simple scenario. So what happens is you can define a max surge value of how many buffer nodes that you want to do. Typically, it's 10% is the range, and if it's one node here, so you have this buffer node come up. Then, like we showcased yesterday in the lab, you will cordon and drain, meaning we'll go as a rolling upgrade. We go one node at a time. So the first node is cordon drained, and the pods, it tries to evict the pod before reimaging. So which means an evicted pod, the Kubernetes controller tries to put it in wherever there is capacity, including the buffer node that's available. So we see them move around, and then the node gets updated. So the new node with the recent image comes up, and then it moves to the next node. Similar thing happens. The pods get moved over to wherever there is capacity. And yeah, it goes in a rolling fashion. So whatever is your surge number, whatever is the buffer node is also right now the number that defines the parallelism, the amount of node that we can cordon drain and reimage at a single point of time. So since one is the buffer node here, one becomes the node to attack by default to cordon drain and reimage. And finally, we have to, right now we try to delete the surge node. That's because we want to try to preserve the availability zone balancing. Zone balancing is important. So in the current algorithm, that's how it works. So we want to start with the same number of nodes and end with the same number of nodes in the upgrade, post upgrade. That brings me to a new feature that we recently announced, is generally available. So by default, before 1.31 versions, they had serial container image pools, and these can be a little bit cumbersome, especially when viewed with larger container images. I know some of you would have wanted a chance to have parallel image pools, especially in the context of after a node image, getting your containers and pods ready. So parallel image pools will be the default post 1.31 version onwards, and that means especially for larger container images, that's a capability. It should make things faster, especially after a node image upgrade. And yeah, we briefly touched upon the struggle with how do you want to stay within a supported Kubernetes version, especially because we're rolling thick and fast, right? Every 4 months there's the version, and 12 months of support per version. So that's one struggle that we saw. And how do you keep your upgrade success rate high and minimize the failure? That's the second struggle that we have noticed. And the third is obviously how do I make sure my workloads are not impacted and there is as minimal disruption to the workload as possible. I'm sure it resonates with many of you here. So if you have to probe that a little bit further, these are some of the double-clicking into it, the reasons, right? PDB misconfigurations. We've noticed about 70% of the cancelled upgrade operations is because of incorrectly configured pod disruption budgets that leads to, because we have to honor PDBs, eviction becomes a problem, and the upgrades get stuck or cancelled at that point of time. Workload disruptions, lack of PDBs, probes, that's another issue. Yeah, go ahead.
So my question is, in case of any failure, how much time it is going to take for the rollback? Is it going to amount the same time?
So currently we don't have the concept of rollback. So what happens in upgrade is it aborts then and there. If there is a, say for example, eviction failure because of a PDB block, it stops there. The provisioning status goes to fail, and any subsequent put, that's what we call reconcile. It kicks off from that point of time. So once, for example, if you've corrected the PDBs or whatever is the source of the problem, then the upgrade commences from that point of time onwards. Or if there is an auto upgrade that's scheduled for the next weekend, it picks up from that point. I touched about the API breaking changes. That's an area where we have reduced a lot of churn because of the feature to fail fast on deprecated APIs. We're trying to constantly improve that part, but it's yielded good benefits for us. I know some of you have also experienced lengthy upgrade time. And one of the things that I want to touch upon in the next slide is there's a property called max surge. So the buffer surge node, that if you can take more surge capacity, it leads to faster upgrades. So it's a directly proportional concept. And of course, the concept of upgrades, given you're talking about production workloads, is never easy, right? So how can you proceed from a lower environment, test, dev, staging, and then to production? For people familiar with Fleet, you have a concept of upgrade groups there. So that's something to look into if you're looking at multi-cluster management. And of course, currently it needs a little bit of documentation, familiarity on the cadence, what are the controls available. So there's a little bit of investment in terms of the skill set, especially on the operator persona. So we're aware of that. We are trying to simplify that. So all things considered, the perfect upgrade doesn't exist, but I know it's quite hard to pull off. So we don't want to pull off a Surya's catch every single time. It should be something like a Rohit Sharma slip catch, right? So that's our objective. So what this AK is doing and how can we help? So we touched on these pieces. So PDB misconfigurations, we have something called deployment safeguards. It's like a guardrails that tells you, okay, enabled, you can flag off these PDB misconfigurations. We're trying to invest more on pre-flights before upgrades. We have some already in place for very basic PDB misconfiguration, but a lot more we are trying to invest. It's tricky, but we are getting there. And we have, I touched upon deployment safeguards for no availability constraints. There is, from our API breaking changes, we have advisor, we have automatic fail fast detection. On the lengthy upgrade time, we have changed the max surge default from 1 to 10%, so that it's consistent across the board. We recommend something like 40% if you can do a max surge. Obviously, that's bound by quota and capacity. We have drain timeout. We have soak timeout as well for pod readiness, application readiness. That's all released. And I'll be introducing something called continuation upgrade behavior. We had a bit of chat about it during the break session, so you will see that soon. And again, in terms of making sure the upgrades are safe and doesn't disrupt anything, I mentioned the lower environments part. So with Fleet Manager, you can do upgrade groups. You can set and forget mechanisms through auto upgrade control with maintenance windows. We have more pre-check validations, especially in terms of quota and some of the system PDBs outside of the user PDBs. We are trying to invest there. So these are some basic things that AKS already has and is continuing to invest. And I briefly touched upon this. So we have an algorithm change that's been introduced in public preview recently. So it's called untrainable node behavior. So what you have to simplify this. You have these 4 nodes in 1.29. Let's just take it. So we're upgrading from 1.29 to 3.0. So node 1, no problem, gets upgraded. Node 2 has a problem with PDB. It gets blocked there. So it's failed to drain. Cordon, typically before this algorithm change, it will fail there, right? So we stop there, we fail, we can't proceed further. But what if there is surge capacity, you don't fail the upgrade then and there, you try to cordon that node, label it as quarantine and just continue into node 3, node 4, as much as possible, push forward and improve the coverage of upgrade, right? So it's all about improving the coverage of upgrade. So a lot of the customers have asked this, so I'm happy to say that this is now available. So it's something, if you're interested to increase the coverage of upgrades, you can do it. And then you can always go to the specific node, handle the misconfigured PDBs, and now you can delete specific nodes in AKS as well. Previously you can't do that, but now that's been available with the machine API for a while. So you can pinpoint a specific node and delete it. I think we covered briefly about PDB. So this is just an example. Pod disruption budget. From the developer track as well, you have min available and max unavailable, how much ever you want to set for the replica. So having the right replicas and right min and max unavailable is pretty important. So here is an example of a narrow restricting PDBs, because you can say allowed disruption is 0. with the min available on a very, very basic Nginx controller. And this one means I can't evict the pod from a node, because allow disruption 0 means I can't evict. And typically that will lead to a drain failure. So we'll look into that and see how the new algorithm helps. So this is what happens. Let's just take that Nginx pod with an arrow restrictive PDB, right? On node 0, there is this pod. We have the buffer node come up from 1.28. We want to upgrade to 1.29. The first pod has no issues. It's moved over to node 3. Second pod is where there is a restrictive PDB and the eviction does not happen. So in this case, typically we'll just fail it. The node gets stuck. We fail the upgrade. We don't proceed forward. But in the new algorithm, this is what is changed. Let's just take the same example. We cordon and drain the first node. Surge node gets created. You move the first pod over. The second pod gets blocked on eviction. And this is where, with the new algorithm change, if you set the undrainable node property to cordon as opposed to schedule, which is what it is today, we'll quarantine. We'll put a label there called quarantined, and then we'll proceed forward, so long as there is surge capacity. So you can see that node 1 gets upgraded. No issues there. And after the upgrade, it gets the pod back as we move to node 2. And then node 2's version is also getting upgraded. And then finally, this is where with the algorithm, we have taken the zonal balance also into equation as much as possible and try to have a replacement. Since you started with 3 nodes, wherever possible, we can bring the surge node as one of the replacement node to the block node. That's what we'll do. Close on the heels of this particular upgrade algo change, we also have something called a communication manager. It's a notification mechanism where for all your auto upgrades, right now it works on auto upgrade. We want to bring more scenarios from AKS there. It uses event grid and Azure resource graph framework underneath. So what happens is on your auto upgrades, we want to give consistent stream of notifications. Hey, my upgrade has started, it is ending. If it's particularly if there is a failure like PDB eviction or quota issue or XYZ problem, you want to see why it is failing, right? The insights is important. So that's what we are committed to doing with the notification manager. So for this, you need auto upgrade channel plan maintenance window as prerequisite. We have simplified this with a webhook, so you can easily connect, plug and play with any email scheduling service like Logic Apps on Azure, but obviously you can also use Jira or ServiceNow or anything that's popular. And we have Azure resource graph queries in the background that anybody in Azure can tap into and know for the same, right? For the same notification, you can see on the queries as well. I have a quick demo. So here you have system topics in Azure. So we have a system topic that is already created. And let's see. So please note that the source here for the system topic is the subscription ID. We have this all given in the documentation. The source type is container service event resources. So it's Azure resource notification system topic that you have to create first. And then we create an event subscription next. So again, in this example, we have already created an event subscription. The endpoint is a webhook. That's something for flexibility standpoint, you can use this endpoint to get all the notifications. So here there is already an event subscription that's pre-populated and created. Please note that the events are streamed across your subscription. So meaning if you have multiple clusters, you're going to get a large body of events, and you would want to have the capacity to filter and have a little bit of isolation, right? So that's where we would recommend a filter within the event subscription. And you can, in the values, key operator values, you can set your resource group and your cluster name as filters, so that as event grid gives all these notifications in, streams is notifications, you should be able to differentiate at a cluster level what is what. And we also recommend for the notifications, because they're all in the webhook, you can use a JSON parser to tap into the message body and keep it simple for your operator persona, so that you should be able to quickly see for this cluster and what is the body of information that's coming through. So the JSON parser is not in the demo, but it's something that we recommend that you do for the notification itself. So after the event subscription and is set, you can create a logic app. This is the part where for the webhook you can use ServiceNow or Jira as well, but easily within Azure, I'm just using a logic app designer. Use the HTTP request and set the. We also have some templates that you can use, JSON templates that you can pre-configure from the docs. It's something to look into, and this is the JSON that you can parse for something that's useful to consume at an operator level. You can use the payload example given. You can give what is the the address that you want to be sent, and you can fine tune the subject also. Put a JSON parser as necessary, and it's done. So after this, I think we'll move into the cluster and set an auto upgrade. So I have this cluster Jisoo demo and a case demo. So this one, I'll just set an auto upgrade channel. Just from a simplicity standpoint, you also have a deployment, just a basic Nginx deployment, and let's say we take a PDB that's very restrictive. So I'm keeping min available as 2, even though there's only one pod to evict. So which means I get into an allow disruption 0, or I'm unable to evict the pods. So just for the sake of demo, we have very restrictive PDBs. And this is the version 28. I also set node image, which is the most commonly used auto upgrade channel that ships weekly VHTs. And I have in this example a default cadence of every week Monday. You can configure it to your Saturday or Sunday, whatever is the less disruptive window for you. And for the sake of demo, we have a restrictive PDB, and let's say the auto upgrade channel kicks off on the designated time, Monday. It should fail immediately because of the restrictive PDB. So you see the agent pool provisioning status goes to failed, and we will get the notification. Whatever you have configured, you should see a restrictive PDB and what is the reason for it, which PDB and which node got impacted. So everything comes in neatly into the notification. So I know there's a lot of words here, but what it says is restrictive pod disruption budget, failed to evict a particular pod. And this is the part I was mentioning. I would highly recommend a JSON parser. Yeah, that's in a nutshell what communication manager is. So it will tell you when the auto upgrade kicked off and what happened at the end. So again, yeah, some key points. I did talk about the JSON parser. It's a webhook, so you can use it. Just an example was the logic apps. You can use as well Jira, ServiceNow, or anything else. The flexibility is important here. And in the documentation, we have a sample payload that you can definitely use in your lower environments, test and see how the alerts are firing before you can get into production on your node image channel or any other channel. So yeah, I think that's it from an upgrade. So what we aim to do is just like Boomerang, right? Any surface, any format. We want to, for any cluster configuration, any workload, we want to make sure the upgrade works, right? And it's easy for you to do. So that's the journey we are in, and hope we can take you along. Thank you. With that, I'll pass on to Ria and the security team.
Okay, third time's the charm. So we have cluster B on the right that lacks all of these security controls. So no role-based access control. That means any user can access or modify the cluster. No network isolation. That means like there can be lateral movement within the cluster, and then unscanned images. That means your cluster is running with vulnerable images. So cluster B here is basically a breeding ground for security incidents and attacks, and is also potential compliance violations, increased downtime or disruption, and it also introduces incident response cost that comes with the remediation effort. Also, like security best practices, it's not like a one-size-fits-all solution. So we need to look at multiple comprehensive security controls across different layers. Emma touched on this briefly during the developer session. And I also wanted to just quickly go over some of these things. So let's start with container and image. So, the life cycle starts with images, and it is important that we secure these images so that the images are running vulnerability-free. For that, there are features or solutions like Microsoft Defender for Cloud that provides you with image scanning or runtime scanning, threat analysis, image integrity. We have Image Cleaner to clean up any like stale or vulnerable images. And then there's private registry connection to secure the traffic between your cluster and the image sources. Then we have control plane and Kubernetes objects. We have like multiple features that AKS offers in terms of like private clusters to provide network isolation, manage cluster identity to add layers of access control and identity and access management. Then we have KMS etcd encryption, which is to protect your sensitive data. Moving on to Node, there are multiple features here as well, like hardened bootstrapping, trusted launch, and secure boot, basically to ensure that your node starts securely. Then there are some advanced features as well, like confidential nodes, dedicated hosts, PON sandboxing, to ensure that your workloads are protected and your data is secure as well. Application and network, Emma did cover most of it in the developer section. So I'm going to skip through that and move on to the next slide. I know, like the last slide was a lot to take in. We had, all of these amazing features and controls listed. So for the purpose of this session, we'll focus on the day zero security best practices. Ahmad also covered a lot of the application side of your workloads in the developer section. So the day zero security best practices mostly involve proactive measures that you need to take to secure your clusters before the workloads are deployed. And that basically like ensures that your AKS environment starts with a strong security posture. And if you think about it, it's like, with all of these layers that we looked at on the last slide, it's like, we need to build a wall that's higher and stronger, and each of these like controls that we briefly discussed is like a brick that we need to use to make that wall. For the rest of the session, split it into cluster deployment and configuration, networking, nodes, so that it's easier for us to walk through and understand the controls that we can follow while we are performing all of these actions. All right, So at the time of cluster deployment and configuration, there are multiple features, controls that are available to you that you can utilize to ensure that your cluster is secure. So starting up like Microsoft Entra ID, I'm going to briefly cover these, and there are I have like deep overview of some of these things as well in the upcoming slides. Microsoft Entra ID integration, this is for user authentication, just making sure that whoever needs to have access has access to the resources. Role-based access control to ensure that we have least privilege access, and then restricting access to the API server, either through private clusters or through authorized IP ranges. Then we have enabling network policies to make sure that the traffic, pod-to-pod traffic, is secure. There isn't a pod that is talking to another pod that it shouldn't be talking to. And then managed identities for cluster resources. This is extremely important when it comes to secret management, since you do not have to manage the passwords that come along with some of the identities. So managed identity is basically a replacement of that, and you're using tokens instead. So there's no like overhead when it comes to managing the secrets. And then Azure policy for Kubernetes, basically to ensure like compliance and security configurations are already in place. And Azure policy helps you identify some of those issues. All right, so one of the most important aspects when it comes to securing your cluster is identity and access management. And in your AKS cluster, any like external request from a user, from a developer, or from an integration tool is routed to the API server through the API endpoint. Now, all of these requests need to authenticate to the API server. That means they need to have access to the API server. That can be done primarily using two ways. One is local certificates, and the other is Microsoft Entra ID. Microsoft Entra ID was previously called Azure AD, and now it's being rebranded to Entra ID. Now, once a user has authenticated, we need to authorize that user as well, which means what actions can that user perform and on what objects. And that can be done, again, using two available options here. One is through using Kubernetes RBAC or through using Azure RBAC. We're going to discuss all of these options in detail in the upcoming slides as well. So let's look at the authentication options. So we have, like I mentioned, we can authenticate a user using local certificates or Microsoft Entra ID. Local certificates is basically a default. If you create a cluster on the portal, you may see like the default local accounts for Kubernetes. So that's what this is. It's using certificates to authenticate local users. And for Microsoft Entra ID, it's basically like a centralized solution where you're creating users and groups to grant or revoke access to resources. So with Microsoft Entra ID, it's obviously easier to manage the access since it's easily scalable. Like if I'm adding multiple members from my team to a group and I'm granting them access to a certain resource, it's easier for me to manage that. On the other hand, with like local certificates, you have to manually grant and revoke access. So Entra ID is definitely like easier, scalable to use when you have a large fleet of clusters or multiple clusters running. Next, just wanted to briefly touch base on, how Entra ID is working with role-based access controls. So we just have, user groups that we created in Entra ID. We have a bunch of users added to those groups. Users and groups, they are assigned to a specific role. So for example, I assign a group cluster admin role, and then that cluster admin has the authority to access all clusters with admin privileges. So that's what the slide here is reflecting. Now again, two ways that you could use least privilege access control in your AKS cluster. The first one, Kubernetes RBAC. So in Kubernetes RBAC, you're basically utilizing the users and groups that you create in Microsoft Entra ID, and then you're utilizing roles, cluster roles, to define the authority or the actions the role can perform, and then you are binding that role with the users or groups that you create in Entra ID. This is great for when you need like fine-grained access controlled to like specific resources within your cluster. Then with Azure RBAC, you could utilize those role-based access controls across like multiple subscriptions, across like multiple resources in your subscription. So this basically utilizes like predefined roles that exist in Entra ID. And we have like a bunch of predefined roles for AKS as well, like RBAC reader, writer, cluster admin, and there are custom roles as well that you can create that would cater to your needs. So these users or groups would be assigned to those predefined roles, and those consecutively would grant access to your clusters or resources. This is, again, ideal for managing access consistently because you would have predefined roles, and it's easier to manage and scale these roles in Entra ID. All right, next up is restricting access to the API server. Like I mentioned, all the external requests from a user or any integration tool for that matter come to the API server and through the API endpoint. And by default, when we deploy the AKS cluster, the API server is exposed to the internet via a public IP address. So it's essential that we make sure that we secure that. In cases where you do want to keep a public endpoint, you could still restrict access to your API server to just specific IP addresses where usually your traffic comes from. So you could do that using authorized IP range and specify an IP or a list of IPs that would have access to the API server. Yeah, we'll talk about that later as well in the networking section. This is just, how do we secure access to the API server at, a very introductory level, but in detail, we can talk about all of that in the networking section as well. All right, another way to restrict access is private cluster, where your cluster is deployed in a private network, and only like private IPs would be able to access your API server. So the last thing in cluster creation and deployment stage is enabling network policies. So this is extremely important when it comes to securing or ensuring least privilege in terms of networking within your cluster. So by default, within an AKS cluster, all pods, or in Kubernetes for that matter, all pods can talk to each other. So there's no like restricted traffic, and we need to make sure that we enforce least privilege access to only allow traffic or to only allow communication between pods or resources that must talk to each other. So you could implement network policies within AKS. We have a couple of options. For example, Azure Network Policy Manager is supported on both Linux and Windows, Cilium, Calico as well. And these options, again, like when you're looking at your workloads, that is something that after analyzing or reviewing the workloads that you have and running on what specific operating system, that's something that you could decide when you are making your decision on which network policy to choose just after reviewing your workloads. Now, we talked about the internal pod-to-pod communication, but like if there's traffic coming from outside of the cluster to the services running within your cluster, for that there are like other means for us to control, and that's something that we are going to be covering in the networking section. And before we talk about like all the controls and fun stuff and security features, just let's take a look at some of the challenges that the operators experience when they are like managing or handling all the traffic, be it ingress or egress traffic. So it takes a lot of careful planning and provisioning of resources and ongoing management when it comes to managing all of the ingress traffic. Since ingress is like the entry point to your cluster and can expose sensitive data as well, it introduces a lot of security risks, and there are also compliance requirements that come along with it, since again, exposure to sensitive data. And then provisioning of all these ingress controllers can also be resource heavy in terms of CPU, memory, and can impact your cluster performance as well. Monitoring ingress and egress is another challenge, and also important when it comes to like auditing or understanding troubleshooting of your ingress and egress traffic. So again, controlling and monitoring of that outbound traffic can be extremely challenging. Similarly, any like inbound traffic, especially non-HTTPS traffic for that matter. So looking at those challenges, it's evidently, yes, networking is very complex, and there are multiple robust features and security practices that you could follow in order to help secure your cluster when it comes to the networking landscape. So here I have securing ingress and egress traffic. Jay is going to be talking about that in detail in just a little bit, but basically utilizing Azure Firewall or network security groups to only allow authorized traffic, deploying ingress controllers like Nginx or Azure Application Gateway. Next up, again, private DNS and private endpoints. So I briefly touched on that during cluster creation as well, that you could create a private cluster that would basically isolate your cluster from the internet and reduces or minimizes exposure to any like public IPs that can access your cluster from the internet. Last one being network isolation. So basically using virtual networks to isolate the workloads. And along the same lines, we also have a fun announcement here. We have network isolated clusters in public preview. So what that does is like we talked about the default behavior as well. So network isolated cluster simplifies restricting the outbound network access, and it reduces the risk of any unintentional exposure of the cluster's endpoints. And that basically secures your data from leakage or exfiltration. What this uses is private link or private endpoint when it comes to utilizing any external services or add-ons in your clusters. And another aspect here is, you have pods running, you would utilize, you would need to pull images from a container registry as well. So in the network isolated cluster, you would have a private ACR, where the images from the private ACR would be pulled using the private endpoint, and the sync happens between the private ACR and the Microsoft Artifact Registry, or MCR. If there are images that you need to access within your cluster, but they do not exist in the private ACR, then they are behind the scenes. There is a sync that happens between the private ACR and MCR to pull the latest images to the private ACR from MCR as well. I have a link on the bottom as well in case you want to check out the feature. Okay, now I'm going to hand over to Jay.
I'm a product manager in Azure networking. So Ria already spoke about various ingress challenges when it comes to getting the traffic inside your AKS cluster. There are plenty of solutions that are available. As you can see on the right-hand side, we have this self-managed options, popular names like Nginx, Envoy, Helium. I mean, obviously there are management overheads for these self-managed options. So you have on the left-hand side, there is this Azure managed solutions. In Azure managed, you have managed Istio, application routing add-on for Nginx. And then recently there is this new release for application gateway for containers. We'll be coming to that in a bit. But before that, the predecessor for application gateway was application gateway ingress controller. Now, the way application gateway ingress controller was designed was it was just an application gateway resource, and it was plumbed to work with the containers. There were certain challenges because config updates used to go through ARM, operations used to get queued, and that was the typical problem. Like updates were very, very slow. There were a lot of complaints, and that's the reason, with a very fresh perspective, application gateway for containers was designed, and this was designed with containers in mind. So it's a fully focused solution for AKS. All right, so now we'll look at the benefits that are offered. But before that, let's just take a look at this diagram. I was talking about the primary pain point that was there with AGIC, which is Application Gateway Ingress Controller, the version 1 I was talking about. So here, as you can see, the purple line and the blue line, your ALB controller now talks to ARM. That is certainly for the deployment of the resource. But at the same time, it also has a direct communication with application gateway for containers resource, which is sitting outside your AKS cluster. So the advantage is that the deployment, for the deployment, it talks to ARM, specifically when you're using the managed deployment option. I'll be explaining that point in a second. But if you want to get your own deployment and just do that, so that your ALB controller can talk to application gateway for container resource directly. So that's how the problem with fast updates was solved. So there is this flexible provisioning models. You can either bring your own deployment if you prefer to deploy the resource yourself and manage the lifecycle on your own. You can do that, or you can just have ALB control the resource outside, which is sitting outside the cluster. So you can go with the managed option, and it comes with gateway API support. Another benefit is vulnerability protection and patching. So being a managed solution, it takes care of zero-day vulnerability patching, which is required. So you don't have to worry about that. Enterprises that needs compliance and attestation, if they have compliance and attestation requirements, even that is taken care of like any other Azure product. As I mentioned, it's sitting outside the cluster, so it doesn't consume the node resources that is required for your workload. Support and SLA is also something which is available, so you don't have to go to different vendors if you're using a self-managed solution. And one of the top requested features is web application firewall. So this was something which was not available so far. Currently, it's in preview. So if you have, any of you want to sign up for preview right now, please reach out and we can sign you up for that. So looking at the features of application gateway, we already spoke about near real-time configuration updates. Uh, and if you have whatever method you want to use to interact with Azure, you can use that, like be it Bicep, PowerShell, Terraform. So that is something which is available with this managed solution. TLS offloading, and one difference over here as compared to AGIC is it also has backend mutual authentication. Plus, it also supports multiple certificates types. So if you want a more performant ECDSA certificate, you can use ECDSA certificates for certain types of clients, but that same listener can also support RSA certificates for other types of clients. Manage resource lifecycle via Kubernetes, we already spoke about. So you either bring your own or you can have it managed through Kubernetes. URL path header rewrite manipulation. So this is something which every L7 load balancer offers. If you want a specific URL to be modified and it goes to the workload with specific pattern or after certain modification of the header, you can also do that. Application gateway for containers being a managed service, it also brings the default native Azure Monitor troubleshooting options like Azure Monitor, Prometheus, backend health and service health integrations, along with round robin. So AGIC supports just round robin, but for application gateway for containers specifically, it also supports weighted round robin. In terms of protocols, gRPC is the new addition that you have over here in AGC, and again, Web Application Firewall. So we'll talk a little bit about features of the upcoming WAF. The WAF is supporting both managed as well as custom rules. For managed, it's DRS, which is default rule set 2.1, and for custom you can use IP or geomatch rules. It also has bot protection and limiting request size for protection from DDoS attacks. The scope is also similar to the WAF policy that you have currently in WAF, where you can apply the WAF scope to entire gateway, listener, or a specific path. Okay, so the next solution, which you typically need for egress traffic or for non-HTTP workloads, as Ria spoke about earlier, is where you can use Azure Firewall. So it's a built-in solution to secure your egress traffic between the clusters. Just a minute, please. Yeah.
Blue-green deployment, right?
Oh, you're talking about multi-cluster support?
Multi-region.
Multi-region.
How does blue-green deployment support? And I mean, you have written there blue-green deployment, right? Let's say multi-cluster, but it's
So multi-cluster support is not available as of now. One ALB controller can talk to multiple resources, but not the other way as of now.
so. How does blue-green deployment work then?
Just a minute, please. Which?
If you go to
Okay, wait and round robin, that is in terms of the pods that you have. So if you want a specific pod, you can assign weights, and that weights will be, and then you can gradually decrease it. So if you want to just move
you're
the
talking
traffic.
about on the same cluster,
Yes,
you're just scheduling the pods. I mean, you're disrupting pods, and then you're
assigning weights.
Assigning-
Yeah, so the traffic is not
there's no
sent like,
downtime on your application.
absolutely, yeah. So you do it gradually versus all at once.
So this doesn't support multi-cluster.
Not as of now.
App routing.
App routing. Sorry, I'll get back on that one. App routing bit. I just need to confirm that. Yeah.
I think it's based on the same, on top of application gateway, right? It's on this supports single cluster.
Uh-huh.
So app routing is on top of application gateway, where it has active kind of setup.
Okay. No, I'll get back
Just
on
want
this
to-
particular point.
Sure. Thank you.
Yeah. So Azure Firewall is a solution which works from layer 3 to up to 7. It has different types of rules that you can configure. Now, you can have NAT rules. NAT rules is basically to have a public IP translate to a private IP. You have network rules. This network rules is somewhat similar to NSG with 5 tuples, but it also supports FQDN based filtering. So that is one advantage. Applications is where you have things like categorization. So you don't need to worry about when it's an egress traffic, the endpoint which is there. If you want to filter it based on a web category, you can use that and it will automatically filter based on whatever rules you apply. Beyond that, again, it also supports FQDN based, SNI FQDN based rules. So the way it works is you can, if let's say there is an egress traffic from within the cluster to outside, it can break open the HTTPS, which is TLS termination the other way. And it will apply the application rules that you've set. Another advantage is that it's a central firewall policy management. So you don't need to work separately for each resource. You can use that same firewall policy and apply it all at once through the policy management feature which is available. Looking at the features, we already spoke about filtering that's available at different layers. It's also highly available and with auto scale. TLS offloading inspection for outbound connections, threat intelligence based filtering, which is there. Again, it's the web categorization. Fully managed signature. So this is something interesting. It's for IDPS, which is intrusion detection and prevention systems. It has 60,000 plus attack signatures, which are based on malware and it's based on malware signatures and also logging with SEM systems. So that's all from my side for application gateway for containers and firewall. I'll hand it back to Ria for the further cluster node slides.
All right, thanks, Jay. The next area or the next vertical that, sorry. Yeah, so the next area that we are going to be covering is the cluster nodes. Think of nodes as a backbone that's running your workloads, and securing the nodes directly impacts the health of your workloads that are running on the cluster. Again, going over certain features or controls that can be utilized to secure or strengthen the security posture of your nodes. First one being auto upgrade. Karthik, covered a lot about auto upgrade in the last session as well. Dedicated hosts where we are isolating the workloads physically so that there's to ensure that there is like resource segregation and there's no data exfiltration across the nodes if you are working with extremely sensitive data. Restricting SSH access. This is extremely important to reduce the attack surface of your cluster. It ensures that there is stronger protection against like any unauthorized access and any lateral movement in case of a security breach. And then IMDS restriction. And with that, another announcement from AKS where we do have IMDS restriction available and it's in public preview. So the IMDS is basically, Azure Instant Metadata Service that provides information about your VM, like your SKUs, storage, or network configuration, and any like access to this information, any malicious actor or a threat actor, if they get access to this information, can potentially misuse it to perform any security threats or risks. So now you are able to optionally restrict access to this endpoint by utilizing or enabling the IMDS restriction feature. So for any non-host network pods that are not sharing the configuration of the host itself, you would be able to restrict access to IMDS. However, for host network pods where you do, for certain pods or services where you do need to share the host configuration, for those, you would still be able to access the IMDS endpoint. Again, there's a link on the bottom if you want to learn more about the feature. Next up, I'm pretty sure all of you may have heard about FIPS, but for those who haven't, it's a federal information processing standard that requires all cryptographic systems to meet certain requirements if they are dealing with any government related traffic. So we, within AKS, also have this feature, which is generally available now. You can easily migrate your existing workloads to be FIPS compliant by just updating them to have FIPS rather than recreating your node pools. Again, link on the bottom if you want to learn more. All right. Another very important aspect when we are thinking about nodes is securing and maintaining them, as in, there may be CVEs that exist in the base image of your node OS. And within AKS, we release weekly VHDs for all available offerings of the operating system. So Ubuntu, Windows, Azure Linux. So it is extremely important to have the auto upgrade enabled, be it node image auto upgrade that, whenever AKS releases a VHD and you have an auto upgrade enabled, you would get a patched image immediately once the VHD is available, and the CVs would be patched. Node upgrade as well, which is upgrading the version of Kubernetes. It has like bug fixes, certain feature enhancement, and also certain CVE fixes as well. So Karthik did talk about this briefly, like utilizing different patch channels when you're working with your AKS cluster. Okay. So as we talked about, node upgrades are critical to maintaining a secure and high-performing AKS environment. But how do we ensure, or what ensures that these upgrades are efficient, secure, and reliable? Well, the answer lies in the operating system that is powering your AKS cluster, and that's where Azure Linux comes into the picture, which is basically a custom-built OS designed to specifically for AKS to optimize performance, security, reliability, and management. So I'm gonna hand over to Poonam, and she's gonna walk us through Azure Linux.
Awesome. And it is optimized Hyper-V across cloud and edge. And sorry, let me start over again so that everybody is at pace. Yeah, actually, have you done this? That would- Okay, so what exactly is Azure Linux? Azure Linux is a Linux-based operating system that we build, sign, maintain, and validate in-house. And I'll start at the base layer, which is the Linux kernel, which is heart of any Linux distribution. So we take the upstream Linux kernel version of 6.6 and then add Azure-specific drivers on top of that. And that's how we get the Microsoft Linux kernel. And it is optimized Hyper-V across cloud and edge with Azure-specific drivers for better performance and security. And then it is hardened by default. So we have hardened kernel, hardened flags, and we support multiple silicon architecture like x86-64 and ARM64. And then on top of that, we have the Azure Linux core, where we have more than 10,000 packages, and all those packages are in RPM format. And out of those 10,000 packages, we handpick just 520 of those packages. And that's how we get the Azure Linux base image. And all these packages are built from scratch to ensure secure supply chain. And we have the CVE available for all the critical CVEs within 5 days or less. And we ensure that all the security patches are available every month. However, for our critical CVE, we provide the security patching within 5 days. Can move to the next one. So Azure Linux 3.0 went GA a few months back. And now we use the upstream Linux kernel version of 6.6, container D2.0, run C1.2, and systemd v255 for better security and performance. And like I mentioned earlier, so the packages are selected specifically for AKS use case, and we do rigorous testing of each of those packages and the image on AKS infrastructure. And this image is available in cloud and edge via AKS. And this also serves as a backbone for kernel level isolation and confidential compute for Kata and Kata CC. And we follow the AKS release process. That is, we release the image on a weekly basis, and we provide patch for all the critical CV within 5 days. And now one company owns the entire AKS stack. So all the feature requests, support requests comes directly to us rather than you having to work with another companies whose product are not necessarily optimized for Azure or Azure Linux, Azure and AKS. And since we are in the same company, that too within the same organization, we can collaborate much more faster on the request. Next slide. And what are the different security challenges which people face is CV overload, and the developers have to spend too much time on the CVEs. And then there's uncertainty around security hardening, and because of large number of packages, there are threats for supply chain. So how Azure Linux help with all those? So we have fewer number of packages in the image, so there's less surface attack and fewer CV patching is required. And the image is secure by default. We have hardened kernel, hardened flag, and we do regular security audit of the image. We also provide the FIP enable image, something like Ria mentioned. And then we pass all the CIS level 1 benchmark, which has more than 200 unique rules. And we are the only Linux distribution on AKS that does so. And all the binaries of Azure Linux are built from source, and they are signed with Microsoft Trusted Key. So I just wanted to briefly touch about how we do the testing to minimize the regression and impact. So as you see, we have the Azure Linux package, and we take the AKS test suite, and we do full testing on performance, security, etc., AKS add-ons, extensions. And once all the test cases pass, it's only then we release the image to PMC or to Marketplace. PMC is a package repository. And then the AKS takes those images and packages and do their round of testing. And once it is tested, it's then only AKS release the image to the end user. However, if you see other distro, they enter into the test suite really late. So we are better tested, and we ensure that we have minimum regressions and customer impact. Yes, please.
So this is. So it's not a Red Hat product, right? It's developed by Microsoft, right? The kernel. Kernel. Okay. So what is the cost difference between the Azure Linux and Ubuntu?
Just so that everybody listens to the answer, yes, we do not fork from Ubuntu. It's a Microsoft product which we build in-house. And currently, we do not have any pricing attached to it. It's completely free.
Okay.
And we do the support from our side.
Okay. Yeah. Thank you.
Any other questions? Okay, all right, thank you.
All right. On to the last area that I wanted to cover in the security best practices session is storage. Let's maybe briefly look at it since Ahmed already talked about this extensively in the developers session. So best practice when it comes to managing or storing your secrets is, not hard coding, not using them within your code or within the Kubernetes secrets. So for that, we have secret management systems like Azure Kubernetes. With CSI Secret Store, it allows the Kubernetes workloads to access secrets that are stored in any secret management system like Azure Key Vault without directly embedding them within the Kubernetes secrets. So it provides a secure integration where it has capabilities to fetch secrets, keys, certificates, any form of secrets when it comes to your Kubernetes workloads, tokens, etc. And the volume is ephemeral, so it ensures that the secrets aren't stored on your nodes persistently. It offers a native Kubernetes workflow, so it has an object that can be used to utilize the secret store CSI driver. And then again, we've been focusing a lot in this session on least privilege access control. So it also has like specific role-based access capabilities that you could define a certain role and use it within Azure AD to grant access to like specific secrets. We covered a lot in the last 45 minutes or so, and still I feel there's a lot that we could talk about when it comes to security. So with that, I'm gonna leave you with this one of the favorite quotes of mine from Bruce Schneier, which is, security is not a product, but a process. And you all may have experienced that, we cannot give you like a checklist or a checkbox that lists you, 1, 2, or 3, and then we are secure. But it's like that consistent effort or commitment to secure our data, our workloads, and there are multiple features and offerings that AKS has that can help you achieve that secure environment. For being such an amazing audience, have a gift card for you. if you take the time to take a quick Kubernetes survey. If one of the first, if you are out of the first 150 people, you will get a chance to win a $10 gift card. All right, thanks everyone.